Welcome to our second day on 1.6 with angle pairs and relationships. Today's focus is we're going to be using algebra to find angle measurements. So at the end of this lesson, make sure that you can do that. All right. So example 1, figure segment QY bisects angle RQZ. Keyword there is bisects. Okay, this segment right here bisects angle RQZ. What do we know from bisect? That means it divides into two equal halves. So you can see from our tick marks right here, this angle is equal to that angle. So we've done problems like this before. In order to solve this problem, we just set each angle equal to each other. So we know that 2x has to equal 3x minus 11 right here. Just then at this point it becomes an algebra problem. Solve for x. Minus 3x minus 3x. 2x minus 3x is just negative 1x, or just minus x, equals minus 11. We want to solve for x, not negative x, so we got to divide each side by negative 1. Therefore, x equals 11. So we found the value of x. Now, we need to use that to find the value of each angle. Well, in order to do so, just plug in the value of x to the expression for each angle. So to find the measure of angle RQY, which equals 2x, we're just going to plug in for x, we're going to plug in that 11. 2 times 11, which equals 22 degrees. So that is our measure of angle RQY, and that better be the measure of angle YQZ, because it was bisected. They must be equal. But if you check, we put 3 times, there's that 11, minus 11, it will equal 22 degrees as well, which is what we want. Okay, next example. Okay, a lot going on in this problem. All right, we've got our intersecting lines, 4 sets of angles. They want us to solve for x and y, then find the measure of each angle. We'll solve for x and y. I'm confident you guys can then find the measure of each angle. So here, the key to this problem is must use angles with the same variables. Okay, so in this case, if we want to solve for x, we've got to pick the 2 angles that have x, which is this angle right here and this angle right here. And then we have to check out their angle relationship. Those are a linear pair because you can see they add up to 180 right here. They're on a line, adjacent supplementary angles. So since that's the case, we know that they must add up to 180. So we have to say 4x plus 8 plus our x plus 47 equals 180. At this point, it becomes an algebra problem. We've got like terms. Let's combine the 4x and the x. So that's going to give us 5x. Let's combine the plus 8 and the plus 47. So that's going to give us our plus 55. And that's going to equal 180. We'll subtract the 55. You guys are familiar with these steps. So I know I can go a little quicker here. So we're going to end up with 5x equals 125. Divide by 5, x equals 25. So that is our x value. Okay, to solve y, we've got to do the same things. Where's our y values? There are these 2 angles right here and here. Again, they're a linear pair. So we're going to set it up the exact same way. Y plus 42. All right, I'll write that down here. We're going to have y plus 42 plus r. What was the other value? It was the 4y minus 12. And that again equals 180. We're going to use algebra again to solve this problem, okay, to figure out what y is. And then at that point, we plug our value for y back in. So using our colors, I've got a y and a 4y. Underlining works, whatever you guys is easiest for you. That'll give us 5y. We've got our plus 42. And we've got our minus 12. So that's going to be plus 30 equals 180. I think you guys know the steps. Subtract 30. So we're going to end up with 5y equals 150. When we divide by 5, y is going to equal 30. So there's our x and y values. To find the measure of the angles, we would then plug these values back in. So again, y equals 30. I'd plug that in for these for y, and x equals 25 would go into these values to find these angles.